So, in the previous class, we have learned about knocking. So, in order to control knocking, generally there are some anti-knocking agents, kind of tetraethyl lead, tetramethyl lead, diethyl telluride. Okay. So, they are called TEL, tetramethyl lead, TML, diethyl telluride, DET. Okay, these are the some anti-knocking agents. Anti-knocking agents. Okay. Yeah. So, along with this, to control the knocking characteristics of a fuel, knocking is mainly due to the fuel. Okay. So, due to its rapid combustion, it releases high amount of energy that causes irregular movement of the piston, which is called knocking. So, in order to control the knocking characteristics of a fuel, okay, we should use best fuel, okay, which avoids knocking characteristics. So, how to select a best fuel? That is the important topic to be discussed here. Okay, one is octane number. What is that? Octane number. Very, very important topic. Octane number. Okay. So, what is octane number? Definition can be delivered as the percentage of isooctane present in the mixture of isooctane plus N-heptane, which energy is equal to the tested fuel. Okay, coming again, the percentage of isooctane present in the mixture of isooctane and N-heptane. The mixture's thermal energy on its combustion, okay, should be equal to the thermal energy produced by a fuel which we are going to test. Then we can name the octane number of the tested fuel as the percentage of isooctane present in the mixture. Okay, I will explain very clearly so that you will understand, right? So first take N-heptane, C, 1, 2, 3, 4, 5, 6, 7. Okay, CH3, okay, CH2, CH2, CH2. This is N-heptane. Okay. So it is a hydrocarbon chain. The hydrocarbon chain is containing 7 number of carbons, and it is a straight chain. Okay. Now another one is 1, 2, 3, 4, 5. Okay. CH3, CH2, CH, CH3, CH3, CH3. Okay? Is it okay? This is called 2,2,4 trimethyl 1, 2, 3, 4, 5 pentane. This is called isooctane. This is called isooctane. Okay, when the researchers did their work on finding a best fuel in terms of knocking, okay, which fuel gives zero knocking characteristics, okay, then they find isooctane is the best one. Isooctane is the best one. Okay, if we use isooctane, which gives the knocking characteristics, okay, which gives the knocking characteristics 0. Its anti-knocking characteristics are 100. Okay, so if you use N-heptane, the researchers find that N-heptane has highest knocking characteristics and anti-knocking characteristics are 0. N-heptane has knocking characteristics 100. Isooctane has knocking characteristics 0. Okay, so if the hydrocarbon chain is in the form of isooctane, its knocking characteristics are 0. If the hydrocarbon chain is in the form of N-heptane, its knocking characteristics are 100. Okay, this is what researchers find. So, with respect to their finding, what they suggested is, just imagine petrol. If the petrol contains hydrocarbon chains. If the petrol containing hydrocarbon chain, that the containing hydrocarbon chain is in the form of N-heptane, that is poor quality petrol, because its knocking characteristics are 100. If the petrol is containing hydrocarbon chain and the hydrocarbon chain is in the form of isooctane, and the hydrocarbon chain is in the form of isooctane, its knocking characteristics are 0. So, the good petrol, the best petrol should contain hydrocarbon chain kind of isooctanes, but not N-heptane. Okay, so that is what researchers find in their research, right? So now let us do one thing. Okay, note this, I am rubbing. So let us do one thing. For example, at our Lindy College, outside of our Lindy College, there is a petrol bunk. Okay, I want to check the knocking characteristics or octane number of that petrol. Okay, this is what? Petrol. Where did I get this petrol from? Outside of our Lindy College petrol bunk. Okay, so good. Take petrol here. Okay, some quantity. Okay, 10 ml or 20 ml. Okay, fixed quantity. So petrol I took 50 ml. Okay, along with that, in the another container, okay, take 25 ml of N-heptane N-heptane and 25 ml of isooctane. Okay, this is called the mixture of isooctane and N-heptane. The volume should be equal, 50 ml. This is petrol. Okay, which petrol? The petrol under test. So, what my aim is to calculate the knocking characteristics of this petrol, to find out the purity of this petrol, to know the octane number of this petrol. Okay, so I am allowing the petrol under test to combustion, okay, which releases some amount of heat. Okay, I have calculated the amount of heat. Okay, I have calculated amount of heat. Okay, so the calculated amount of heat, okay, denoted as X and kept aside. Right? Now, in another container, we have 50 ml of sample that is containing 25 ml of same quantity 50 ml, but the 50 ml should be taken in the percentages. Okay, 50% of N-heptane and 50% of isooctane. 50% of N-heptane and 50% of isooctane. Okay, now I am allowing these contents to undergo combustion. That releases some amount of heat. Denoted that heat as Y amount of heat. Now observe one thing. If the two energies are equal, X is equals to Y, okay, when will be the two energies equal? Okay, when the test fuel combusts, it gives some amount of heat that is equal to the reference sample containing mixture of N-heptane and isooctane, having 50% of N-heptane in the mixture and 50% of isooctane in the mixture. Okay, so this heat is equal to this heat. Okay, when the X is equals to Y, then we can say the octane number of this petrol as 50. The octane number of petrol as 50. Sir, how can you do that? Okay, yeah, the octane number can be defined as the percentage of isooctane present in the mixture of isooctane and N-heptane. Okay, its thermal energy is equal to the thermal energy produced by a fuel under test. Sir, I have a doubt. If the N-heptane is 20% and isooctane is 80%, okay, this will be under combustion and gives some amount of heat, and the test fuel gives some amount of heat. Both the energies become equal. Then what will be the octane number? Obviously 80. How? Because this 80 is given depending upon the percentage of isooctane present in the mixture. In this way, you can test any of the fuel which you want to test. Okay? Yeah. Why I choose these two? Because one is having 0 anti-knocking characteristics and the other one is having 100 anti-knocking characteristics. One is having 100 knocking characteristics and the other one is having 0 knocking characteristics. Such kind of reference samples I have taken. Okay, with that reference samples I am comparing the fuel under test. Okay, this is octane number. Hope you understand. Right? Yeah. Next one is cetane number. This is for petrol. Octane number is for petrol quality and cetane number is for diesel. Okay? Yeah. So when the researchers have a question that whether the diesel is pure or not, okay, they have gone through several analysis. In their analysis, what they find is 2-methyl naphthalene. What is that? 2-methyl naphthalene. Okay, 2-methyl naphthalene, which is having 100 knocking characteristics. Highest knocking characteristic containing having highest knocking characteristics holding by this kind of compounds, cyclic compounds, aromatic compounds. Okay, next another one. Another one is CH3, CH2, 14 times CH3. Okay, this is called decane, cetane, hexamethyl decane. Okay, this is called cetane. The cetane, it is a straight chain. Okay, the cetane is having knocking characteristics 0. Here the knocking characteristics are 100. Here the knocking is 100. Here the knocking is 0. Here the knocking is 0. So the researchers find that if the hydrocarbon chain is in the form of CH3, CH2 14 times, CH3 cetane, okay, its knocking characteristics are 0. If the hydrocarbon chain is in this form, its knocking characteristics are 100. This kind of structured hydrocarbon chain possess more knocking. This kind of structured hydrocarbon chain possess less number of knocking characteristics. Okay, less amount of knocking characteristics. So now you came to know which one is best among the two. Okay, obviously this kind of structured hydrocarbon chain is best one. So take diesel. If the diesel is containing hydrocarbon chain in the form of 2-methyl naphthalene, it is a bad fuel. If the diesel is containing a hydrocarbon chain in the form of cetane, it is a very good fuel. It is quite opposite to the previous one, octane number, because their straight chain hydrocarbons are bad. Okay, branched chain are good. In this case, okay, aromatic rings are bad, straight chain are good. Right? So this is about the basics of cetane number. Now coming to the point. Okay, take a container. Okay, the container contains diesel. Okay, which is under test. You are going to find whether the diesel is good or bad. Okay, we have collected the sample, diesel sample from the petrol bunk near our institute. Okay, next, this is containing reference sample. What is the reference sample? Okay, this contains 20% of, for example, you can take 30 also. Okay, for your convenience, I will take 30%. This contains 30% of 2-methyl naphthalene, 2-methyl naphthalene, and 70% of cetane, and 70% of cetane. Okay, this is mixture. Okay, now I am allowing the two samples to undergo combustion. Okay, during the combustion it releases some amount of heat. Okay, now calculate the amount of heat. If the two heats are same, then you will give the Cetane number to the diesel which is under test as 70, where the Cetane number is 70. How it is 70? How it is 70? Because the mixture is containing 70% of cetane. Okay, the mixture is containing 70% of cetane, and its thermal energy is equal to the fuel which is under test. That's why I gave the Cetane number as 70. Likewise, octane number. Right? So, can you define Cetane number now? Yes. Cetane number can be defined as the percentage of cetane present in the mixture of 2-methyl naphthalene and cetane. Its thermal energy is equal to the thermal energy produced by a diesel sample which is under test. Okay, so here the percentage of cetane is 70%. That's why I gave Cetane number as 70. Okay, yeah, this is all about octane number and cetane number. Okay, next concept is power alcohol. If ethyl alcohol is used as a fuel in internal combustion engine, it is called power alcohol. Generally, the percentage of ethyl alcohol is ranging from 5 to 25%, because ethyl alcohol is having very good anti-knocking characteristics. And also it absorbs water. Okay, and increases the efficiency of the IC working. Okay, so if the ethyl alcohol percentage is more, that is called power alcohol. Okay, yeah. Next one is biodiesel. You know what is biodiesel? Okay, the diesel is prepared from plants. Okay, yeah, by using natural products, kind of plants. Okay, so if you are able to extract the fuel from plants, okay, and using there as biodiesel. Okay, other than traditional methods used to prepare biodiesel. Okay, by using natural ingredients. Okay, so you do one thing: prepare power alcohol and biodiesel. Search about power alcohol and biodiesel. Okay, in Google, so that you will be able to know what is the research is going on, the two things, because it is very, very important to you as you are a mechanical student. Okay, it will be better to do your final year project on power alcohol and biodiesel. That's why I am leaving it to your knowledge. Okay, do the best one. Okay, so this is all about liquid fuels, right? Thank you.